Hello, future scientists! Are you ready to embark on an exciting journey beneath the surface of our planet? Today, we're going to explore one of the most important substances in our modern world, crude oil. It's something you might have heard about in the news or seen in movies, but do you know what it really is, or where it comes from? Today, we're diving deep into the earth to discover crude oil, a thick, dark liquid hidden far beneath our feet. It's found in places you might never expect, from deserts to deep under the ocean floor, and it plays a huge role in our daily lives. Crude oil isn't shiny like gold or precious stones, but it's so valuable that people call it black gold. Why is it so important? Well, crude oil is the starting point for making gasoline for cars, jet fuel for airplanes, and even plastics and medicines. It powers cities, helps us travel, and is part of thousands of products we use every day. But where does crude oil come from? The story begins millions of years ago, long before humans walked the earth. Back then, ancient plants and tiny sea creatures lived and died in vast prehistoric oceans. When these tiny organisms died, their remains drifted down to the sea floor. Over time, they were buried by thick layers of sand, mud, and rock. This process happened slowly, over countless centuries, as more and more material piled up on top. As millions of years passed, the weight of all those layers pressed down, creating intense heat and pressure. This incredible force slowly transformed the buried remains into crude oil and natural gas, trapping the energy of ancient life deep within the earth. The energy in oil is actually ancient sunlight, captured by plants and animals long ago and stored away for ages. When we use oil today, we're unlocking energy that began its journey with the sun millions of years in the past. Crude oil is a fossil fuel, a non-renewable resource. That means it takes millions of years to form, and once we use it up, it won't be replaced anytime soon. This is why it's so important to use it wisely and look for new ways to power our world. You might imagine oil as a giant underground lake, but that's not quite right. Instead, oil is trapped in tiny spaces, called pores, inside special kinds of rocks known as reservoirs. These rocks act like natural sponges, holding the oil until we can extract it. Above these reservoir rocks, there are layers of hard, non-porous rock called cap rocks. These act like a lid, sealing the oil in and keeping it from escaping to the surface. Without these cap rocks, the oil would seep away and be lost forever. Finding these hidden pockets of oil isn't easy. Geologists and engineers use special tools and technology, like seismic waves and drilling equipment, to search for reservoirs deep underground. It's a bit like being a detective, searching for clues buried in the Earth's layers. When they finally strike oil, it's like uncovering a liquid history book, one that tells the story of our planet's ancient past and powers our present. The journey of crude oil, from prehistoric oceans to the fuel in our cars, is truly remarkable. So, what do we actually do with crude oil, this thick, black liquid that comes from deep beneath the Earth's surface? You might be surprised to learn just how essential it is to our daily lives, even if you never see it in its raw form. In its raw state, crude oil isn't very useful. It's sticky, smelly, and can't be used directly for much. But once it's processed, it becomes the backbone of modern civilization. Crude oil is sent to massive refineries, where it's heated, separated, and transformed into a wide range of products that we rely on every single day. This process is called refining, and it's where the magic happens. The most important products are fuels, like gasoline for cars, diesel for trucks and buses, and jet fuel for airplanes. These fuels keep our vehicles moving and connect cities, countries, and even continents. Without oil, travel and transportation as we know them would be almost impossible. Delivering food, medicine, and goods across the globe would become a huge challenge. But oil's impact goes far beyond just fuel. Crude oil is the starting point for plastics. Think about water bottles, toys, packaging, and even the keyboard you might be typing on right now. Plastics are everywhere, and most of them start with oil. Oil is also used to make asphalt for the roads we drive on, fertilizers that help our crops grow, and synthetic fabrics for the clothes we wear. From the streets beneath our feet to the shirts on our backs, oil plays a hidden but vital role. Even some of the things you might not expect, like crayons, makeup, and certain medicines, are made using oil-based ingredients. It's woven into the fabric of our everyday routines in ways we rarely notice. This single substance is the building block for thousands of materials and products. From electronics to packaging, furniture to footwear, oil's reach is almost limitless. Oil connects people, powers our world, and is part of almost everything around us. It lights up our cities, keeps our homes warm, and helps generate electricity in many places. It's hard to imagine modern life without oil. From the moment you wake up and turn on the lights, to the time you travel, work, or relax, oil is quietly supporting your day. That's why crude oil is so valuable. Its price can affect economies, influence politics, and even shape the course of history. It's not just fuel, it's the foundation of our daily lives, woven into almost everything we use, touch, and depend on. The story of oil is, in many ways, the story of modern civilization itself. How do we find oil hidden deep underground? The answer lies in a fascinating blend of science, technology, and a bit of detective work. Oil doesn't simply announce its presence. It's locked away beneath layers of rock, sometimes for millions of years, waiting to be discovered by those who know where and how to look. Geologists are earth detectives, searching for clues. Their job is to piece together evidence from the land, using their knowledge of geology to uncover hidden secrets below our feet. They study rock formations, analyze samples, and use maps to predict where oil might be trapped. Every rock tells a story. Its color, texture, and composition can reveal whether oil could be nearby. By carefully examining these details, geologists can narrow down the most promising locations. Sometimes, oil seeps to the surface, hinting at bigger reservoirs below. These natural seeps are rare, but when found, they offer valuable hints about what lies beneath. Geologists use satellite images and aerial photos to spot patterns in the land that suggest oil could be present. Subtle changes in vegetation, unusual landforms, or even faint color differences can all be clues. Modern technology allows scientists to scan vast areas quickly, making the search more efficient than ever before. Offshore, special ships use sonar to map the ocean floor, searching for the right conditions for oil. These vessels send sound waves deep into the seabed, creating detailed images of the layers below. This helps geologists identify the best spots to investigate further, even in the most remote parts of the ocean. They also study the history of regions. Ancient seas are prime spots for oil. Millions of years ago, these areas were covered by water, where plants and animals died, sank, and were buried, eventually forming oil. Understanding this history helps geologists predict where oil might be found today. Drilling small core samples helps confirm if the right rocks are present. These samples are like time capsules, revealing the layers and materials hidden deep below the surface. By analyzing them, scientists can tell if the conditions are right for oil to have formed and been trapped. If they find both a source rock and a reservoir rock, they know they're close. The source rock is where oil forms, while the reservoir rock is where it collects. Both are needed for a successful discovery. It's a careful process of narrowing down the search area. Every clue, every test, and every observation brings the team closer to their goal. It can take months or even years of patient investigation before a promising site is chosen. Only after all these clues line up do they pick a spot to drill. The decision is never taken lightly. It's the result of countless hours of research, teamwork, and expertise. Oil exploration is a scientific treasure hunt, blending curiosity, skill, and technology to unlock the Earth's hidden resources. Every discovery is a testament to human ingenuity and our drive to understand the world beneath our feet. Once a promising area is found, geologists use seismic surveys to see underground. Thumper trucks send vibrations into the ground. Sensors called geophones record the echoes. These echoes reveal the shapes and layers of rocks deep below. Powerful computers turn this data into 3D maps, showing where oil might be trapped. Different rocks reflect sound waves in unique ways, giving clues about what's hidden. This technology lets scientists explore miles underground without digging. It's like using a giant stethoscope to listen to the Earth's secrets. Seismic surveys are essential for finding oil safely and efficiently. They help decide exactly where to drill. When the spot is chosen, it's time to drill a well, sometimes miles deep. A massive drilling rig spins a tough drill bit through layers of rock. Drilling mud is pumped down to cool the bit, carry rock cuttings up, and control pressure. Engineers carefully manage the mud to keep drilling safe. As the hole deepens, Steel pipes called casing are added and cemented in place to strengthen the well. The drilling crew works around the clock, adding pipe sections as they go. It's a complex, high-tech process that can take weeks or months. Drilling is the only way to reach the hidden oil. As drilling nears the target, the team watches for signs of oil, changes in rock cuttings or pressure. When the drill breaks into the reservoir, it's called striking oil. Engineers detect oil in the drilling mud and run tests to measure how much is there. Modern safety equipment keeps the pressure under control. No wild gushers. If the well is promising, they install a system of pipes and valves called a Christmas tree to control the flow. The drilling rig is removed, and the well is prepped for production. The exploration phase ends, and oil production begins. The team's hard work pays off as ancient oil is finally reached. The well is ready to bring oil to the surface. At first, natural pressure pushes oil up the well. This is primary recovery. As pressure drops, pump jacks, those bobbing metal machines, help lift oil to the surface. Water or gas can be injected into the reservoir to boost pressure. This is secondary recovery. These methods help get more oil out than pressure alone. Even then, much oil remains stuck in the rock. Enhanced oil recovery uses steam, gases, or chemicals to free even more oil. These advanced techniques maximize how much oil we can extract. Each stage helps get the most from every well. It's a blend of engineering and creativity. The goal: bring as much ancient energy to the surface as possible. Once oil reaches the surface, it's mixed with water, sand, and gas. At the production site, separators use gravity to split these apart. The cleaned oil is sent through pipelines, vast networks that move oil across continents. Pipelines are monitored for safety and leaks. Offshore, oil may travel by underwater pipeline or be loaded onto giant tankers. Tankers carry millions of barrels across oceans to refineries worldwide. Before refining, oil is stored in huge tanks near industrial areas. This transportation network is vital for getting oil from the well to where it's needed. Every step is carefully managed to protect people and the environment. Oil's journey is long, but essential. It connects distant wells to the products we use every day. Let's recap. Millions of years ago, tiny sea creatures became crude oil, storing ancient sunlight. Geologists hunt for clues, use seismic surveys, and drill deep wells to find it. When oil is struck, engineers control the flow and start production. Pump jacks and advanced methods help bring more oil to the surface. Oil is separated, transported by pipeline or tanker, and stored before refining. At the refinery, it's turned into fuels, plastics, and countless everyday products. From ancient life to your car's gas tank, oil's journey is a story of science and engineering. It's a reminder of our connection to Earth's deep past and the importance of using resources wisely.